Now for before and after, there are several different types. Okay, let me just list them out here. So we have those that is single unchanged. Oops, single unchanged. We have the total unchanged. We have the difference unchanged. Yeah, the everything change. Yeah. Yeah. So the hardest is of course the everything change.
Level 2, level 3, level 4.
Yeah, all these three are almost like the same category, right? So there's another name.
Unchanged. That's the boss.
Yeah. Another name given to this is units and parts.
No. It's everything changed, not everything unchanged. Oh. Everything unchanged means we solve the question. We have nothing
if everything unchanged,
we have nothing to solve. This is the best question. We have nothing to solve.
Okay, so one name, another name given to this is units and parts. Now sometimes all these there are different names as well. Like I don't know, do you all know any other names given to what? Single unchanged, unchanged, no? I know that there are other names. There are other names given.
I know one digit unchanged.
One digit unchanged.
No, that's not single unchanged. Yeah.
Okay, so what I'm going to do is I'm going to just go through the first one. Okay, so before and after that, these are all the different variations of ratios that you can see and that actually came out right in the PSLE. So question number 1, a shopkeeper bought some pens and pencils in the ratio 2:9. We have pen is to pencil. Ratio 2:9. So after he sold 612 pencils. Now what I like to do is I like to call this the before and after table. Before, then plus, minus, and then something happened, and then after. Now this method, right, is not invented by me. No, don't say Mr. Teng method, right? These are taught in class in schools, right?
Oh, yeah,
some of you already learned it in school.
This is not Teng Tech.
No, this is not Teng Tech, right?
Teng Tech is for science, bro.
This is everywhere. Okay, once again, it's everywhere. Honestly, I have no idea who created this thing, but I use it.
Whoever created it is the one who's gonna figure out. I don't like do this method.
You don't
one
use
who created it.
But after using and after doing so many years of PSLE, I find this method pretty easy to follow. Yeah, I find it one of the easiest methods, so I just continue to use it. Okay, I think it's discovered by MOE school. Yeah, they teach them.
MOE schools are.
No, MOE. As in, I ever went to their website to check the syllabus and what you need to learn. So they have something like that. Okay, wait, so let's go through together. Oh, you have answers. Oh, that's fast. Yeah, so let me just wait. Let me go through this first. Okay, so pencil 2:9. Then you see after he sold 612 pencils, that means here plus under the plus and minus must take away 612, and then the ratio became 3:5. Got that? So we know that this is before and after single unchanged. So how do we know that it's single unchanged? Matthew? Yeah, why?
Pen
yeah, pen remain the same. So what do you do to the ratio when pen remain the same? Yeah, what is the common multiple?
6.
Great. 6. Okay. So if this is 6, the top row we multiply by 3. So it becomes 27. This is still minus 612. The bottom row we multiply by 2. So it becomes 10. And then we can continue with the calculation. So if you take 27, take away 10 units, that is 17 units. 17 units represent 612. So 1 unit will be, you can use a calculator, 612 divided by 17. 36.
36 times 6, 216.
Yeah, so how many pens did you buy? So pens 6,
6 and 6.
So 36 times 6. What is it again? 216. So June, you're correct. The answer is 216. 216.
I get 26.
What was it?
Oh,
no, that's not correct. Okay, 216. Something is wrong. Please take a look.
You don't think I know that?
Okay, yeah. Question number 2 of before and after. So Susan had a box of blue and red bits in the ratio 7:13. So blue is to red. 7:13. And this is the before. Then something happened, plus, minus, and then we're after. Okay, so we're done. Then she removed an equal number of blue and red bits from the box, and then the ratio became 1:3. After that, became 1:3. So this question is the difference unchanged. Okay. Why is it called difference unchanged? Because if you were to remove the same number, you remove an equal number from both.
So the difference
the
is
difference
still
is the same. Okay, however, if you look at the original number here, it gives us 6, and this is 2.
No,
right?
2 make it 6.
Yep. So the bottom row got times 3. Okay, so that I can get a new set of ratios. And what is my new set of ratio? B is to R. Matthew, can you go back to see? 7 is 13. 6. Okay, so I got multiply by 3 at the bottom. 3 is 2. And once I got the difference, which is the same, I can find out, right, what percentage of bits were left in the box. I do not need to know like what is the amount that was removed, because I already have the before. I have a certain number, and then after I also have a certain number. So before that I have 20, and then after that I have 12. So the percentage of bits left is 12 over 20 times 100%. Okay, so number of bits left, 12 out of 20 times 100. And you guys are correct. Okay, 60% is the final answer for this. Okay, well done. So you see what happened here is that you need to know the difference unchanged. Okay, to be able to solve this. The first one was single unchanged.
I'm
right?
single.
Of course, I can't be married. Huh? Okay, next two. Okay, number 3. Maybe look at this first.
John is gone, so.
Hmm?
3 put thumbs up. Our brains. Yes! Our brains are connected.
No.
What is that? Wow.
Yeah, that.
Are you sharing answer?
Okay, let's go through this now. Let's go through this now. Right. So Anne had a total of 285 blue bits. She used 45 red and 40% of the blue. So I have 2 different colors, right? Red, blue. Okay, at first there are 285 blue. Okay. We do not know how many red, right? So this question mark. Used 45 red, so minus 45. And 40% of the blue. After that, the ratio of red to blue was 1:3. So I got 1:3. Now this is in terms of units, yeah. So now my problem is I need to know what is 40% of the blue. Okay, so I take 40 out of 100 times 285. Okay, what do I get? 0.4 times 285. 114.
114 out of 285.
Huh? So we minus 114. Right? What fraction of bits did blue bits did N use? So for part A, part A, part A is only asking you what fraction of a blue bits did N use, so we don't need the rest.
Because people working out now. No. I typed it wrongly.
Actually, you don't even need the 114, correct?
I typed it wrongly. Please.
Because she used 40% of the blue bits, right? Yeah, so it's literally just 40 over 100, correct? Which is I think 2 or 5.
Okay, it's 40 out of 100. Dang it!
What do you do?
Why? I did it. I did the 114 method.
Yeah, it's fine. Yeah, that's
How
good.
am I so dumb?
Okay, so that's why Alex, don't worry. You're not dumb, right? I tell you already, it's always the easy questions. You know what I mean? So we
No,
don't.
it's not easy, guys.
No.
This question is easy.
Part A was really simple. You didn't.
Easy. This is medium.
No, part A, you didn't need to do all this weird thing. You know what I mean? You just need to take 40%, 40 over 100.
But once you find A, I think B would be easy.
Okay, let's take a look. Right? So B, everyone have different answer except for Ziyi and Vera. So we got to verify.
Huh?
We got to verify whether y'all got it correct. Okay, how many bits did N have in the end? So we're gonna
I'm straight.
yeah, we're gonna go through this one. So let's use this table. Now you see, if you take 285, my working here. So 285 minus 114. Wait.
171.
Yeah, 285 minus 114 is 171. Now 171 represents 3 units. So what is 1 unit? Is 3 UR. So I want to find 1 unit.
1 unit is 57.
So 1 unit is 57. So the wait. Yeah, so this number here should be 57, right? Yeah, because this number is 171. Why do you need times 4?
In the end.
In the end.
What?
You know?
Times 1. In the end, bits is 1 U because no bits in the end. This is total bits.
How many bits?
Oh dang it!
No, wait, bits. What are you talking about?
Wait, so the answer is what?
Wait, you see how many bits?
Bits is bits.
Yeah, it's the total number of bits.
Blue and red.
The number of bits.
Oh, no. Hello. Oh my god. No, you genius.
Okay, guys, chill. Relax.
Let's go to
Relax. Okay. So final answer. You can either take 171 plus 57. Okay, or you can just take 57. Now what do you do? Times 4.
I thought it's number of Let's go, Ziyi. Let's go.
Okay.
You know, I keep thinking there are 2 people in this class. 2 people in this. I thought 8 was directly.
So we have 228. Oh, right. So I'm gonna go through this right now. Okay. So at first the ratio of boys to girls was 4:1. So what I'll do is I'll just write boys is to girls. So at first 4:1. So this is the before. Next, so after 6 boys and 6 girls join the club, so I'm gonna plus 6 here and here also plus 6. The ratio became 3:1. So after that, the ratio became 3:1. So the question is, did the percentage of members of boys increase, decrease, or remain the same? So just by looking at this ratio, okay, we're supposed to come up with the conclusion. Now, can you tell me what is the percentage of boys at first? So we want to find out percentage of members who are boys. What's the percentage of boys at first for part A? We take 4/5 times 100, right? Which is equal to, you can use a calculator, just 80%, correct? Okay, at first, this at first. Then after that, what happened? Became 3 out of 4. So 3 out of 4 times 100, what do you get? Quarter is 75%, right? So what happened to the percentage of boys? Increase, decrease, or remain the same? Decrease what? 80 to 75?
Everyone got it wrong.
Correct. So the percentage decrease.
Oh my God.
Wait. So I'm very curious. Why didn't you get this?
No, because I actually read it wrong. I didn't say
wrong?
percentage.
Yeah,
So
what's
I
percentage?
compared the ratio.
Oh, you look at
I
the number.
technically actually missed A, so I just look.
Oh, you just look at
You just increase by
the...
6. Maybe increase by
Okay, Alex, what happened? What do you do for this? Did anyone go and find like a total number, then after that go and calculate?
I read wrong.
Yeah, don't have one. Right, you just need to look at the total. Why not? Total here, and then you can calculate that. Is it easy? Easier? See, I told you guys, it's the easy questions. Okay, let's continue with question number B. So in the end, how many boys were there in the club? So we have two answers. Someone said 54. Someone said 48.
It's 54.
So we're gonna check and see what is it actually. Now, so in the question, so they gave us this clue, right? That 6 boys, 6 girls joined, which is why I have this before and after ratio over here. So we plus 6, and then we plus 6, and then we have 3 is to 1, okay? Then 4 is to 1. Now this ratio is actually what we call the difference unchanged. Now why is it difference unchanged?
Because even though they
add the
added the
same number, same number, right? Which means that I can actually have another column, right? D stands for difference. So 4, 1 is 3. The difference is 3. And 3, 1, the difference is 2. Now, I don't have enough space here, so I'm going to go at the bottom and I'm going to create another table with the difference the same. So you see, this is 3 and this is 2. What is the common multiple between 3 and 2?
6.
Yeah, 6. I'm going to use green to show what I'm going to do. Right, so if I want to make this 6, difference of 6 and 6, the first row I got to times 2, the last row I got to times 3. Hence, I can come up with my new set of ratios. Here times 2, so I'm going to get 8. 2. Right here, times 3, so I'm going to get 9 is to 3.
There's too much acid. I cannot.
And it's plus 6, plus 6.
We didn't ask you to do a challenge.
Yeah, nobody else to do anything. Okay, wait, guys, come. So you see, so from here I can tell that 1 unit equals to 6, correct? Yeah, so 1 unit represents 6. The question is, how many boys were there in the club at the end? So at the end, this is the after. What's the number of units? 9. Are you okay? Mathematics is gone. 9 units. Yeah, stop drinking the Coke. Okay. So the answer is 54. Yeah, because you just take 6 times 9. You're going to get 54.